Model-driven programmability. What exactly is it, and why do we keep hearing about it? What exactly is wrong with the CLI? Well, here's the thing. We all know that the CLI is our old friend. It's very, very human readable, and it makes it very good for us as humans to interact with a networking device. Now, one of the glaring errors we have when using or relying upon a CLI is the fact that it is not standardized. So if you've had the joy or the pain of working in a multi-vendor environment, you'll understand that managing many devices with many different syntaxes can become a little bit cumbersome. This is especially true when we want to introduce automation. Because here's the thing with automation, we want things to be as simple as possible, as repeatable as possible. And every time we introduce a new device with a different set of configurations, a different approach to the CLI, then it just means there's more additional logic we need to build into our code to account for that change. And when we're dealing with large, complex networks, we want robust, stable and reliable solutions. Now here's another problem with the CLI. Natively, you do not get your output returned to you in the form of structured data. Now admittedly, reading structured data is not exactly the most easy thing to read on the eye. Again, it's one of those cases whereby it's much easier for the human to read the basic CLI output than to get this structured data, but this structured data gives us so much more value in a programmatic world. In fact, when we have structured data, we're easily able to parse and target particular pieces of information. Whereas with the CLI, to get the exact information we need to rely on the very complex and cumbersome regular expressions. Now that's certainly not to say that regex is not very powerful and not very useful, but the fact remains is that it is a little bit more difficult to use than simply parsing through a Python dictionary. Now here's another problem with the CLI. We also have pretty limited options when it comes to error reporting. And even when the error is pretty explicit and easy for us as humans to understand, it's not exactly the most easy to consume data for our programs. So for example, if we happen to incur an actual error within our system, we would want that error to be able to trigger a change within the automation system. But in order for that to happen, the automation system has got to be able to parse that error to detect it in the first place. Quite simply, it's not enough just for us as humans to be able to read the error with the human eye. We've got to be able to translate that data to our monitoring system. So what then is the alternative? Well, the alternative is right there on the page. It is model-driven programmability. But what does that actually mean even? So what we want to do is to have our data to be consumable in the form of a data model. Well, the difference here is that data models can be thought of as something that is agreed upon, that has strict rules and regulations where we all follow the same format. So if you reach into your wallet, you can see something which is going to denote a data model. If you happen to pull out your driver's license or, for example, a credit card, you can see that the card actually follows a very strict set of rules. Rules which are widely agreed upon that everyone understands. So let's just say you had a credit card here. And I'll just play fast and loose with the facts here, but play along. So let's say that my credit card starts with the letter J for John, then a dot, and then it has my surname, which is McGovern. And along the front of the card, we're going to have the actual credit card number, which is going to be 16 digits. So 1, 2, 3, 4, 3, 3, 2, 2, 1, 1, 2, 2, and 4, 4, 5, 5. And let's say it's got an expiry date of maybe say 09 in the year 2025. So this here is actually a very simple data model. In the case of the credit card number, I had to actually specify 16 digits and they all had to be digits. If I happen to change this to 123K, 33QQ, this would denote a clearly defined error. We're breaking the rules. Similarly, when it comes to the date, if we're using this format, if I happen to change the 9th month to the word September, this would also be an error. Because according to this data model, what we need to have are digits only. But how does any of this help us with networking? So when we apply this concept of model-driven programmability to the network, we are able to enforce syntax and semantics much more rigorously. The knock-on effect is that it allows us to have much more granular control, and it also gives us much more predictable results, which in turn translates to more robust network solutions. Now, the data modeling language that we've all kind of got together as network engineers and agreed upon is Yang. And Yang allows us to be very expressive and very flexible in how we describe our network, but it also crucially allows us to impose these very strong constraints. So say for example we took a VLAN. Within our data model, just like with our credit card number it had to be 16 digits, in the case of our VLAN ID it has to be between the number 1 and 4096. That is a very strict constraint we are able to enforce upon our device configuration. And in fact, that should actually be 4094. I'm breaking my own data model here. So that's actually a perfect example. If I put in the value of 4096, I would have a clear breach of the contract we have with the data model. So let's take a look at another example. Let's say we were defining an interface state. Within our data model, we would be able to specify that the interface state must be either the value up or down. No other values allowed. You can't say on and off. You can't say good or bad. Everyone agrees if an interface is up, it's going to be up. If it's down, it's going to be down. Very strict constraint, very predictable. And we can see that directly just by looking at the Yang models. So if we take a quick look at the Cisco iOS XE VLAN Yang data model, we can see that when we're creating a VLAN, we can see that we have a very strict range, a constraint of 1 to all the way to 4094. Similarly, if we go and take a look at the Cisco iOS XE interfaces state Yang model, our interface state can be down or it can be up. And if it's down, it's going to get the value of 0, and if it's up, it's going to get the value of 1. And it's these small details that make up the core philosophy of model-driven programmability. With Yang, we have the ability to be very expressive in describing our network, but we also have the ability to be very precise and lock down exactly what we want to specify. The resultant impact means that we get a lot of control, a lot of predictability, and a lot of consistency. And these are all three key components to managing large distributed, robust automation systems. So I hope this has been informative for you, and I'd like to thank you for viewing. So in the previous nugget, we had looked at the brief overview of data models and the data modeling language Yang. Similarly, what we also covered were some of the shortcomings of our good old friend, the CLI. Now, the CLI has served us very well for a long time, but you're going to see that it does fall short in many critical areas. And one of the key areas where the CLI falls short, and one of the key reasons we're moving towards this modern programmatic way of managing networks, is because when we configure the device via the CLI, those commands can be atomized. And instead, with modern APIs using things like netconf, we want to be moving away from a configuration that can be atomized and broken down. Instead, we want to be able to impose our configuration as a programmatic transaction. But right now, these are just words, so how about we look at an example and see how this shakes out. Okay, so super simple network topology, if you can even call it that. What I've got here is a CSR device running Cisco iOS XE, and this device is capable of being managed from the CLI, and it can also be managed via the RESTconf protocol. And what we're going to see is the difference between managing the device using the CLI, which can be atomized, and we'll compare that to this model-driven approach, which is going to deploy the configuration as one transaction. So let's dig in. Okay, so before we start, let's open up this device here, and we'll first start off by issuing a show access lists. So straight away, we can see that we have a clean configuration, no access lists are present on the box. So what I'm now going to do is pull up a terminal then. Okay, so let's automate the network, or the one device that is our network, and we're going to automate it with Ansible, and we're going to interface with this device using the legacy CLI. So let's first start off and write a playbook then. We'll say vim example1.yml. Okay, so let's just first start off and give this playbook a name, shall we? So we'll give our playbook access control list configuration. This will be our name. And the host we'll target will be the routers group. Now, as it transpires, I only have one router, so it's only going to target device R1, but we'll stick with the routers group. Gather facts, we're going to say false, we don't want to do that. And the connection type we want to use is the network CLI. Now let's add in some variables, we'll say vars, and we'll say CLI, And the CLI username we're going to log in with is going to be John, which is my name. And the password is going to be Cisco because I'm so creative and all my passwords are pretty much always Cisco. Okay, so let's first create a task then, shall we? So the task name is going to be, what will we just say, configure access list maybe? Okay, now to interact with the device using the legacy CLI, we're going to be using the Ansible iOS config module. So we'll say iOS config. And what we need to do is specify a list of lines that we want to send to the device. Okay, so let's concoct an access list then. So we'll say deny, we'll say deny IP, and we'll deny the loopback range. And we'll do that to any. Let's create a new entry. We'll also say deny IP for the multicast range. We'll also deny the range for the 10.0.0 network, again going to anywhere. We'll also deny the private range, similarly, for the 172. And that'll be 15, that will be. Going to any. And we'll also deny the 192.168 range. This is going to be some type of anti-spoofing access list. Now, what do we always need to have at the very end? If we're going to have a deny, we want to also permit the rest of the traffic in this case. So, permit IP any. Now, Ansible conducts what is called imperative automation, which means that we have to have all of these commands preceded by a certain command, and in this case it's going to be the name of the access list, and we can specify that using the parents option. So the name of the access list we'll say is IP access list, and we'll make it an extended list, and we'll just call it firewall. Now we want to print the output, so we'll register this, and we'll register this as the variable ACL outputs. And then lastly, to print it on the screen, we need to debug this. So we'll say debug, and the variable is going to be ACL output. Okay, with a quick eyeball, this looks okay. Let's run the script and see what happens then. Okay, so let's execute this by saying Ansible playbook example1.yaml. So everything looks a-okay, and you're probably wondering what exactly is the problem here, John? Well, like I say, if we go to the device and arrow up, and as you can see, everything has worked out a-okay. But this isn't the problem with configurations that can be atomized. The problem lies in when we have an error, when we have a mistake within the configuration. Let me show you. Okay, first let's remove this configuration again. So we'll say no IP access list, extended firewall. We arrow up, and now that access list is gone. Let's go back to our terminal now. Okay, vim example1.yaml. Now here is the thing, okay? Because we're interfacing with the CLI to implement our configurations, what exactly is happening here is that the CLI is taking this command, and then it's taking this command, then this, then this, then this, and then this. It's sequential, it's piecemeal, it's bit by bit. Let me show you the problem here. Let me just say we had a really complex configuration here. Or even not, let's just say we just got a little bit lazy and typed in a simple typo. So now, can you guess what is going to happen here? Trust me, it's not going to be good. Okay, clear. Let's rerun this then. Ansible playbook example1.yaml. Oh, and Ansible tells us that the script has failed. We've got an error. Now this isn't the problem. If it actually just failed, then this would be quite fine. The problem is that it kinda failed, but it kinda was also successful. Let me show you what I mean. So let's open up this device then. Now remember, we didn't have any configurations on this. We previously wiped them. This is just what we pushed just there. So say show access lists, and look at that. Can you see the problem? Effectively, we have black holed every piece of traffic we can get, because we successfully pushed out the deny statements. However, when we got to the permit IP any, that was where the error happened. And the problem is that because the configuration could be atomized, it could be broken down line by line by line and taken one by one, the CLI was gradually accepting it bit by bit. So it basically accepted a partial configuration. This is super dangerous. So if this was an enterprise device, and we implemented this at the very edge of the network, we could quite simply, or quite easily rather should I say, black hole all the traffic for all of our clients by implementing this erroneous configuration. But we do have a better option, and that is by using programmatic transactional configuration. So let's look at a model-driven approach using the RESTconf protocol to see how it shakes out and what the difference is. Okay, so let's first actually remove this configuration then, so I've got a clean slate again. Tell if I actually would remove it. I'll say no. Just confirm that's gone then. Show access list. Okay, great. So let's do the same thing with RESTconf. We'll create a script called example2.yaml. Okay, so this one we will name configure ACL via RESTconf. And again, we'll target the same host, which is going to be routers. The connection we'll say is local. And let's go about creating our tasks. Okay, so the name of this task is going to be, if I can type, configure ACL via RESTconf. And we'll specify the URI module. And the URL we're going to send the request to is going to be, so we'll say HTTPS, and we'll use the Ansible variable of Ansible host, which will populate our actual IP address of the device. And we'll say /RESTconf, /data, and we'll just work through the actual native data model. We'll say native IP access list. Now the user we're going to take is the Ansible user variable, and this will translate to the name John or the value John. Password, similar, we'll use the Ansible variable password of Ansible password. Now the method we're going to use one of our CRUD operations, and the operation we're going to use is the update operation, which in HTTP terms translates to a put request. Next we need to specify the headers we're going to use, so we'll say headers, and the content type is going to be application, / and because we're using model-driven programmability, we're going to specify Yang data we're going to send, and JSON. Similarly, we're going to have the header for an accept, and that too is going to be application / Yang data plus JSON. And we'll also specify application Yang data, dot errors, and JSON. Next we'll specify the body format is going to be JSON again. This is the beauty of using RESTconf, we don't have to stick to XML. In the body, this is what we're actually going to send to the device. So I'm going to call a value of ACL configure, and we'll see what that is in a little second. This is in effect going to be the ACL, the access control list, structured in its Yang format. So I'll say validate certs. This is a test environment, so we'll leave this at false. And the status codes we should expect are either 204 or 200. Okay, so what we'll do is we'll save this, but before we actually run the script, we'll go and inspect what this value actually is, this ACL configure. So let's cd into the host vars folder, and we'll do vim r1. Now this is the key which we're going to call ACL configure, and everything under that is what we're going to send to the device. So this is our access control list, and it's formatted in YAML, but it's following the Cisco iOS XE native Yang schema. All of this data strictly complies with all of the Yang rules. But the important thing we're going to focus on is that this is not going to be sent in an atomized fashion. We're not going to send this part of the configuration, then this part, then sequence 30, then sequence 40, so on and so forth. What we're going to do is programmatically take this as one whole chunk and send it to the device. So if it's valid, it's going to accept all of the configuration, but if there's a slight error anywhere, it's going to accept none of the configuration. It's going to flat out reject everything. It's going to reject the whole transaction. So the good thing here is that we're not going to get this dangerous partial configuration which we saw with the CLI. So let me just demonstrate the exact same thing, but over this model-driven programmability method. So we'll scroll all the way down here, just like before, and again what we're going to do is misspell the word permits. So with the CLI, we had the exact same typo and it accepted every single command until we got to the last line of the access control list. We're going to replicate the same thing over RESTconf, and we're going to see it's going to reject the entire configuration. So let's save this with the error, and we'll say Ansible playbook, and we'll say example2.yaml this time. Okay, great, we've actually got an error which we expected. It has failed. But let's go and verify that the device has not accepted a partial configuration like the CLI did. So we'll go into our device, hit enter, and we'll do show access lists. And as we can see, no configuration has been in fact pushed. So what we'll do is we'll go back and amend that mistake then. So let's go back into the host vars, go into vim r1, and we'll fix this typo. And let's rerun the script. And now everything is a-okay. Let's go to the device and verify the change. Okay, back to the device. Let's arrow up. And boom, there we have it. Access control list has been pushed as it was expected to be. And when we made that typo, we didn't accidentally push a very dangerous partial configuration to the device. Instead, this entire configuration was treated as one whole transaction. You either take everything or you leave everything. And this again is one of the key reasons why we're gradually migrating away from the CLI and into the modern age of API-driven network automation. So I hope this has been informative for you, and I'd like to thank you for viewing. So now we've got a broad overview and a rough sense of why the world of networking is moving towards model-driven programmability. And as we've found out, at the very core of this philosophy is the data modeling language called Yang. So let's dig into some of the key details of this modeling language. Okay, so Yang has 1, 2, 3, 4 node types. So the very first node type that we're going to talk about, and it's the simplest one of all, is the leaf node. So when I say it's the simplest type, it's the simplest component of the Yang module. Now here's what to remember, is that a leaf node only has one value of a specific type. So you might be asking, what do I mean by type? Well, a type could be something like, say, a binary value, or perhaps a string value, or maybe a Boolean value, so on and so forth. There are many of these types within Yang. These are built-in data types. Now the second node type is a leaf list object. So a leaf list is a series of leaf nodes of a specific type. So each node has a value, but there are no child nodes. Now the third node type we have is the container. So a container is used to pull together nodes, common nodes within a subtree. Now a key distinction of the container is that there can be a maximum of one instance of a container throughout an entire data tree. Now here's the thing with containers, they only have child nodes, there are no values. And the fourth node type is the list object. Now similar to the container, a list has got no value, only child nodes, but a list may exist in multiple instances of the data tree. And every instance within this list is going to be uniquely identified by a key value. So these are the 4 different node types that you're going to see when exploring Yang data models. And understanding these 4 node types is going to give you a better handle when you're exploring and interrogating a Yang model. It's going to help you be able to make sense of what you're reading. Now here's another important concept. We also want to be able to understand the leaf attributes of a Yang data model. So the first attribute is going to be the config attribute. So here's the thing, within Yang we have this concept of having configuration data or state data. State data is sometimes referred to as operational data. So a classic example of this would be to look at the Yang model for an interface. So within the Yang tree you're going to be able to have options to configure the interface. That would be to maybe add a description to the interface or add an IP address. But other types of data within that interface are actually not configurable, they're just there for diagnostic purposes. Things like your interface counters, you don't configure them, that is just simply information which you read from the device. More broadly speaking, you can kind of imagine the config data as things you will be configuring when you go into global configuration modes, with the good old conft. And the state data relates to your show commands, so for example, show interfaces. But how does that relate to this leaf attribute here? Well, this config attribute is going to be able to determine if the leaf is actually configurable or not. And you can be able to determine that with the type, the Boolean type of true, meaning yes, this node can be configured, or false, meaning no, this node is actually just operational state data. Now here's the important thing to note, is that if the config attribute is not specified within a leaf, then it's going to be inherited from its parent container. So if you look at a leaf node and you don't see anything about whether it's true or false, if you can configure it. So if, for example, this leaf here didn't actually specify whether or not it was configurable or not, what you would do would be to look back up the tree to see where that node came from. So say, for example, the interfaces container, if that was configurable, then this leaf node would also inherit that attribute. However, if the container was, say, interfaces state, in the case of the IETF models, its value would be config set to false, which means that this leaf value would also inherit that value. Okay, so the config attribute is a real big one. Now we also have the default attribute, that's a little bit more simple. That just specifies whether or not you have a default value for this leaf. Here's the third one, the mandatory leaf attribute. This specifies whether or not the leaf object is mandatory, whether it has to be present or it doesn't have to be present. Again, this is going to be a Boolean value of true or false. Now the next one is the must leaf attribute. Now this is where you can specify a particular constraint that must be enforced on this leaf, and we would specify this constraint in the form of an XPath. Fifth, we have the type. Now we already looked at those built-in types. Those are things like strings, booleans, integers, so on and so forth. So for the leaf, you can specify the type and also a range for that leaf. So you might specify a data value of integers and a range of 1 to 4094. The next one is the when attribute. This is very much like programming logic where we have conditional statements. So this attribute would only be present when a particular XPath expression is true. Now the seventh attribute is pretty self-explanatory. It is the description attribute. Now the purpose here is to give you a little bit of context, some human readable text to be able to understand the actual Yang model. Next, and I'm running out of space here, we also have the reference attribute. This just provides a reference, a human readable reference for another type of specification within the model. And number 9, we have the unit attribute. This provides the unit of value we're going to be using within the model. So maybe the actual value within the leaf is going to be 1000, but is it megabits? Is it gigabits? You can specify that unit of value using the unit attribute. Now finally, number 10, we also have the status attribute. This literally just tells you the status of this leaf. Is this leaf up to date? Is it out of date? Is it no longer supported? Is it obsolete? You can find this information by referring to the status leaf attribute. Now I know this is a lot of information to take in, but it really is important that we understand all of the core components that make up these Yang models. It's going to make it much easier for you to be able to read and interpret this data. And all of this kind of information is going to come in very handy later on within this skill when we explore the Yang models in detail themselves. So I hope this has been informative for you, and I'd like to thank you for viewing. Now that we've seen some of the deeper details of Yang, how about we explore it a little bit further using the very popular tool and my personal favourite, PyYang. So PyYang is an absolutely excellent tool to be able to interrogate and inspect your Yang models, and you can install it using pip or, if you like, pip3. So what I'll say is pip3 install PyYang. So as you can see here, it says requirement already satisfied, and that is because I've already installed this library. But if you've not, then it's going to run through the installation very quickly, and then you'll have access to this very, very powerful tool. Okay, so we now have PyYang installed on our system, but what we need to be able to do is to have access to the Yang models, and we can get that via Git. So the first thing I'm going to do is create a new directory, and I'll just call this, I don't know, PyYang demo. And let me just cd into this directory. Okay, so we've got a clean directory, but the first thing we're going to have to do is go to the GitHub repository, which houses all of the Yang models. So let's go there. So if I just search for Yang GitHub, and what I'm going to do is click this top link right here. Okay, so this GitHub repository, this houses all of the known Yang models. We have folders for experimental Yang models, standard Yang models, which would be for things like IETF, and we also have the vendor models. Now the vendor models are also known as the native Yang models. But here's the thing, what we want to do is to download all of these models so we can inspect them using PyYang. And it's super simple to do. All we do is go to the code here and download the link it provides. So we'll click this and copy this link, and we'll take this to our terminal window. Okay, so git clone and then just paste in that address. Okay, perfect. We've now downloaded all of these Yang models. Let's go and inspect them then. So if we do an ls, we go into the folder Yang and ls again. Now what we're going to see is the folder structure which we just saw on the GitHub repository. We have the experimental folder, the standard folder, and the vendor folder. So the first one we'll inspect will be the standard folder. This will be for the IETF, which we can see right here. So let's go into that folder. Then what we want to do is to go into the RFC folder. Now if we do an ls, we're going to see all of these open standard Yang models. Okay, now with PyYang we have a lot of options with what the tool can actually do. If we say PyYang and then -- help, you're going to see some of these features. So you can get filters, you can get information on errors, you can print out trees, you can print out different things like sample XML skeletons. But the one which I happen to use the most, by far the most popular in my opinion, is the tree format. This is going to pull out all the information within the Yang model and present it to us in this nice little tree structure. Okay, so let's get the interfaces model, so I'll just do an ls and grep for interfaces. Okay, so this is the one we're going to inspect here. Okay, so the syntax is as follows: PyYang f, and then we want a tree structure, not a T structure. And then all we need to do is specify the name of the model, which is going to be IETF interfaces.yang. And bam, there you have it. PyYang has transformed this Yang data model into this nice, visible, easy to consume tree structure. So let's just scroll up to the very top of the tree. Okay, so to help make sense of what we're looking at here, let's look at this in parallel with the actual Yang model itself. So let's go back to the GitHub repository. Let's go into standard. We'll go into IETF, into the RFC, and if we just scroll down to the interfaces Yang models, let's go in and inspect them then. And when we're going through this model, you're probably going to notice some of the concepts that we talked about in the previous nugget. Things like the description and the reference. But this part here, this is the part which I want to talk to you about. This is where we can see one of the 4 node types. So the 4 node types we had were leaf nodes, leaf list nodes, container nodes, and list nodes. So straight away here, we can see that we have a container node. And that container is called interfaces. Now within this container, within it, we have a list object, and that is called interface. Now if you recall from the previous nugget, we talked about that a list has no values, it's got a set of child nodes, and the way we can access within that list is by specifying a key. So the key in this part is going to be the name. And by name, what I mean is the leaf, which we can see from the description happens to be the name of the interface. So if this were a RESTconf URL, we would have something like interfaces, which would be the container. Then we would go into the interface list, and then we would need to specify the key, which would happen to be the leaf. And the key in this case is going to be the name of the interface, so this could be equal to gigabit Ethernet 1. But what I want to do is show you how this is mapping to what we can see in PyYang, and how PyYang makes it quite easy to follow this. Okay, so the Yang model has the container interfaces, and PyYang has pulled this information out and denoted it right here. Now within that, we're going to have the list object called interface, and we can see by following this little indentation here, that interface is part of the interfaces container. So like I said, we've got this list object called interface. Now how we can tell that this is a list in PyYang is because we see this little star here, you see that? Anytime you see a star in PyYang, you're thinking of list or leaf list. Okay, so PyYang tells us that we have the interface list with the little star, and in square brackets it tells us what the key is for that list, and it says the key is the name leaf, which is exactly what we saw on the left hand side here. We've got a key called name, which happens to be the leaf. Now within this list is made up of leaf objects. So all these here, these are our leaf objects. And remember what we learned about leaf objects, leaf nodes have one value of a specific type. So in the case of the name leaf, it has one value, so for example, gigabit Ethernet 1, and the value is going to be a string value, that's a type. However, in the case of enabled, the type is going to be a boolean value, which is a true or false. It's either going to be enabled or not enabled. Now here's the thing, not all of these happen to be leaf objects. Now maybe you can spot what ones are not going to be a leaf object, and that is the ones where we see the star yet again. So our higher layer IF and our lower layer IF, these are our leaf list objects. So each of these nodes has a value but no child nodes. And again, if we consult the actual Yang model on the left, we're going to see that checks out. So let's just do a search for higher, and there we can see it there, higher layer if, and that is a leaf list object. And again with PyYang, we can just eyeball that because we see the stars. Now here's the thing, we get down to this value here, statistics, but what do you notice next to statistics? There's nothing here, but it contains a lot of other nodes within, a lot of child nodes. So it's got all these child nodes, but it doesn't have a value. That means that it's going to make this a container. And if we just search for statistics, we're going to see this right here, statistics, which is a container. Now what you can see here, down the left hand side of the tree, we also have this container called interfaces state. Looks very, very similar, but you're going to notice that everything here is RO. We've got no read-write, and that is because everything here is just operational state. That is because the interface's state container has nothing to do with actual configuration. These are the show commands. So this container here is called interface's state, and crucially what you're going to notice is that there's that attribute, config. Remember we talked about it in the previous nugget. We said the config is going to be either true or false. True is for data which is configurable, and false is for data which is not configurable. So it says here config false, and that checks out because everything here is all read-only. So the tree format is super helpful for inspecting Pyang data, but that's not all what Pyang can do. Okay, so let's go in and check another model then. We'll go into Yang, and this time we'll go into the vendor native models. Go into Cisco, and perhaps we'll go into XR. And we'll just pick a revision, we'll just say 7671 maybe. Okay, so Pyang allows us to inspect the Yang model, but it also allows us to build an XML skeleton of the Yang model. So I'll just do an ls, and I'll get for NTP. What I'll say is Pyang f, and I'll say sample XML skeleton, and then I just give it the name of the Yang model, which in this case is going to be Cisco iOS XR, and we'll do ipntp.cfg, or rather -cfg. And boom, you see that? It's actually built us the entire Yang model in an XML skeleton. Now I happen to find this very, very useful as a quick way to be able to build our subtree filtering within netconf. So I could maybe just grab these, for example. So we just paste that in, then all you would have to do would be to close off the tags. Admin types, and then just close off the NTP tag. Now this is obviously a very simple filter, but using the XML sample skeleton, it really does make building these XML skeletons for subtree filtering really, really easy. And this again is just another useful feature of the Pyang library. So I really would recommend you download it and explore all your Yang models. So I hope this has been informative for you, and I'd like to thank you for viewing. I've got a confession to make. So far I've been selling this model-driven programmability stuff pretty hard to you. But honestly, it's not all roses. One of the glaring errors in 2021 is that still today, is that dealing with Yang, the tooling is just not quite up to scratch. You've probably noticed when I've been going through these Yang models, there's a lot of them, and each of them are very large, very expressive. And to be honest, it's quite difficult to find the exact piece of information you want within this sea of all these Yang models which are rich and full of data. So whilst we wait on the world to catch up and invent some really strong tooling for Yang, what I've found more often than not is me relying on good old fashioned Linux tips and tricks, and that's what I want to share with you in this nugget. Okay, so we've downloaded our Yang models and we do an ls. Now we've got all these folders, and within these folders there are a lot more folders. So suppose you wanted to find information relating to maybe the routing information base, the rib table. What you might do is go into, I don't know, cd vendor, ls, then go into Cisco, then ls, then maybe look for xe perhaps, and then choose one of these revision numbers, and then maybe say ls, and then grep for rib, and nothing turns up. So you repeat the same process, going through different folders trying to find this information. But honestly, there's a much better way just using some good old fashioned Linux tricks. So let's go back and start again. Okay, so we're back at the root of the directories. So what I'm going to say is find and then start from this folder. And then I'm going to give it the parameter max depth. Now max depth is how many folders, how many directories down do we want to go. Now let's say I didn't know how many folders this actually comprised and how many subfolders were below this level. Then what I would do would just be to go high. So say I suspect that there may be 3 or 4 levels below this. Well, I'm just going to choose 7 because I know that 7 will certainly encompass all of those levels. And then within wildcard, I'm just going to choose rib. So any models which include rib, if the word rib comes after something or before something, we're going to catch either which way. Then if we hit enter, we're going to get absolutely nothing because I've forgot another parameter. What we need to do is specify the name option. Okay, try again. Okay, so now we're actually going to rifle through all of these directories looking for rib. Now, as you can see, this was still quite a crude search. We've found things like rib, which is what we were looking for, rib. But what about in this one? Can you see rib here? So because we used a wildcard, we actually managed to get subscriber as well. But even still, we've cast a wide net, but still, even using that wide net, we've still managed to gradually filter down those values quite a lot. But I've taken note that there actually is a lot of models called subscriber, and I don't want them to be present, so what I'll do is I'll up arrow, and I'll use the pipe to add in another grep filter. So I'll say grep, and I'll say -v for an inverted grep. So what an inverted grep is going to do is say, we don't want this value. So if we see the word subscriber, we don't want that. So let's try again now, hit enter. Now here's the thing, we've actually managed to pull out those subscribers apart from, we've actually got these subscribers here with the capital S. So we want to refine our search a little bit more by making this case insensitive. So we'll say -I. So now if we look at all the results, we can see all of these ones which contain rib in them. And we can actually see the path to where to find them. So if I wanted to find this one here, for example, I know I could quickly find it in the vendor folder, Cisco XR652, and then there I would find this model. Really quick way to identify what you're looking for. And as you can see here, we've got a bunch which all comprise of iOS XR. Maybe we can add in another filter to just remove anything with XR. So it's grep, again -v to do an inverted grep, and take out XR as well. So now look at our results. But that really is just covering for Yang models which have rib in the actual name of the model. What if we wanted to find all things which happen to have a particular, say, container or a leaf? So say for example here, if I go into CD vendor and then CD Cisco XE, let's say I wanted to find everything which had BGP. If I do an ls here and just grep for BGP, okay, that shows me all the ones which have BGP within the actual name, but you'll notice there actually are models which have BGP containers, BGP leafs. So if I say PyYang F3 and I take the Cisco iOS XE native Yang model, and I'll just grep for BGP. Now this isn't exactly the prettiest picture, but you can see that within this model there actually is a BGP container. So simply searching for the name doesn't actually tell us all the information we want. Okay, so what I want to do is look within the model, see if there are any containers or leafs with the word BGP in it. But I don't want to look within the file, I just want to get the name of the file where they are present. So the way I can do that is say egrep-lr, and then the name of the keyword which I want to search for. So I want to see all instances, all models which have BGP within them. And I want to search within this directory, so I'll say dot. So this shows me everything here which is related to BGP. So you'll notice that within this search, this actually includes the native Yang model, even though it doesn't say BGP within the name, because within that native model, we actually have a BGP container. But let's say we wanted to become even more explicit. Let's say we wanted to find all instances which have a BGP container, but are using the OpenConfig Yang model. So we don't want any of these vendor-specific native models. Well, what we can do is use this same search, but use another filter on top of that. Use a grep to filter out all these native models. So let's try this again. We'll arrow up. Now, before we send this command, we'll use the pipe. And what we'll do is we'll just grep for OpenConfig. So now we see all the models which have BGP within them, but are also OpenConfig. So let's take, for example, the OpenConfig network instance. Doesn't have BGP in the name, but we've been reliably told by our grep search that there is a BGP container present within. So what I want to do is use our favourite tool, PyYang. We'll say PyYang F3, and we'll take the name of this model here. Now, I don't just want to read it, I want to redirect it into a file. So we'll just call the file, I don't know, maybe output.txt, whatever. So the results of this PyYang tree are within this text file here. Now, let's say I was looking for a BGP container, which was a config container. What I would know to look for would of course be BGP. We know that's going to be present because we found that up here. But what we also know about configuration nodes is that they're going to be read-write RW, whereas state is going to be RO. We'll say BGP and RW, that will give us BGP configuration. So let's search within this text file for that combination. But here's the thing, we don't just want to search. What I want to do is do a grep, case insensitive, and give me the number line. Whereabouts in the file do you find this match? And then the match is going to be RW for read-write BGP. and then we just give it the name of the text file we want to actually search, which is going to be output.txt, which houses our PyYang tree. And there's a result there. We've found a container called BGP within this Yang model, and it's on line 219. So now we can take that information on line 219 of this output text file. We can see the tree for the BGP container. So another Linux tool we can use here is more, and all I'm going to do is specify the line number, so 200 line 9's down, and then give it the name of the file, which is output.txt, and hit enter, and boom, it takes us right here within the network instances Yang model, and there we have it. We've got our tree right here. We've got our BGP container. Within that, we've got a global container, and we can see that within that global container, we also have an AS leaf, so on and so forth. And we can do this for pretty much any Yang model we want. Okay, so to quickly recap, you see in more real time, we'll say egrep lr, we're going to look for BGP, anything which contains BGP, within this folder, and we just want open config models. That gives us our shortlist right here. Let's grab a model to select. We'll take this one, and we'll make our PyYang tree, so PyYang f tree, paste in the model, and we'll create an output called text.txt, whatever. Then we'll do a grep, case insensitive, give me the number, or the line number should I say. In this case we want read write, BGP, within the text.txt file. Again we see it's line 219, so we just do more, 219, and then text.txt. And there we've quickly identified the read-write config for the OpenConfig model network instances. And the way we were able to zero in on this exact piece of data was not through any kind of fancy tooling, it was just through some basic Linux, some tips and tricks. So I really would encourage you to explore the basic Linux tools available to all users, because quite honestly they really come in handy when dealing with Yang in my opinion. These are just a few of my favourite, but I use a lot more all the time. So definitely explore that and check that out. So I hope this has been informative for you, and I'd like to thank you for viewing. Now so far throughout this skill, our good old friend the CLI has taken a bit of a hit in the PR sense. And the last thing I want you to do is to come away from this skill thinking that the CLI is dead and gone and has got no more use. In fact, truth be told is that the CLI is still probably one of my favourite tools to be able to use Yang. Yeah, you heard that right, using the CLI to construct Yang data model payloads. So what I want to do is to highlight the workflow to do this, and also point out a really big red flag. A bit of a gotcha that you've got to be aware of just in case it catches you out. Okay, so how about we dig in then, shall we? Okay, so here's the thing. Earlier on in this skill, we had a nugget devoted to transactional configurations, and in that, we were able to use a transactional configuration to push out an access control list. So let's just look at that payload again, shall we? So like I said at the time, is that all this data is Yang compliant and that it has been written in YAML. Now you might look at this and think, well, this looks like quite a difficult payload to be able to structure. And quite honestly, I would agree, if you had to do this manually, then it would be a bit of a problem. But here's the thing, in order to construct this payload, what I did was configure it all via the CLI. You see, it's really easy for us as network engineers familiar with the CLI to configure the thing we want to be on the box. We just give our access control list name and then pop in a bunch of different rules. Now, once that configuration is on the box, what we then want to do is to use a protocol like netconf or restconf to pull that data off the box and have it be returned to us in its Yang data modeled format. So let's say we wanted to build a payload that was Yang compliant for BGP. Well, the first step is going to be configure it via the CLI, because we're comfortable doing this. Once we've configured our BGP on the box, the next thing we'll do is use restconf to pull it back to us in its Yang structure formatted in JSON. After that, we can just do a basic conversion from JSON to YAML, and that will give us all the data we need to be able to house that configuration as variable files in YAML. So we'll go to our device, and we'll keep this a very basic configuration. What I'll say is router BGP 65001, and I'll say BGP router ID is all the ones, and then what I'll do is say neighbor, and we'll maybe say all the twos, and we'll make this iBGP, so it'll be in the same autonomous system number. and we'll maybe change the timers on it. So timers will be 5 and 15. Okay, super easy config. So if we do a show run section BGP, there we have it on the box. So what we want to do is send a restconf get request to pull this data off the box and have it be returned to us in its YAML structure. So let me quickly pull up a script then, shall I? So I'll say vim get.yaml, and what I've got here is a very generic script. All it's going to do is pull the native Yang model off the box, pass in our username, our password, send a get request, and specify that we want our data to come back to us in its Yang structure, formatted in JSON. We're going to register that as the variable called getter, and then we want to print that output in JSON. So I'm going to make a slight amendment to this script in that I don't want to pull the full native configuration off the box. I just want to pull the routing configuration because we just want to have that BGP information. So if you use PyYang to inspect this native Yang structure, we can see that the container within native is going to be called router. So let me just save this and run this script in. And what I'll say is Ansible playbook get.yaml. And there we have it. We now have our Yang compliant BGP configuration structured in JSON. So what we want to do is take this information, convert it from JSON and put it into YAML. Now it just so happens that Ansible adds on this additional key here. We don't need to copy that. So what I want to do is copy from this curly brace here all the way down to the second last one. And just copy this. And then what I'm going to do is search for the website JSON to YAML. And then I'll just remove this example configuration here and paste in our payload. So now we have the JSON we copied on the left and then the translated YAML version on the right. So this is the one we want to copy then. And let's go into our host vars yet again. And you know what, I'll just remove the one with the access control list and just rebuild it. Okay, so paste this in. Okay, so in order to push this configuration, we want to specify a key to call this payload and just amend the indentation a little bit. And you can call this top level key anything you want. You can call it BGP, you can call it IPv0, you can call it CBT nuggets, but I'm just going to call it BGP configure. So BGP underscore configure. And then what I need to do is to indent everything by 2 spaces. And there we have it. We've now got our valid payload which we can send to the device. And what we'll do is we'll maybe change these values then. So we'll change this to 30 and change this to 10. Just so we've got something different to push to the device. Okay, so what I'll do is I'll copy that script from earlier on in the skill. So ACL restconf, and we'll call this one BGP restconf. And we'll go in and amend this. Okay, so let's change the task name here. We'll change to configure BGP. The URL we're going to send this put request to is going to be /native/router. And the body is no longer going to be called ACL configure. In fact, it's going to be called BGP configure. Okay, so let's just save this and try running this script then. And everything seems to have went A-OK. Let's go and check the device. And we do a show run section BGP. And there we have it. We've successfully updated our configuration and pushed out the values 10 and 30 for our timers. So it was through using the CLI that we were able to easily build this payload. Here's the thing, there is a gotcha to watch out for. And quite honestly, this is something I learned through experience. I did not find this anywhere in any kind of documentation. So watch this. Let's go back into the configuration then, shall we? So go back into router BGP 65001. And what I'll do is I'll add the network statement 23.23.23.0 with a mask of a /24. So clearly this configuration is on the box. We have the network statement. This network has been advertised. And in fact, let me just add this as a loopback, just so there is no ambiguity here. Okay, so show IP BGP. This prefix has clearly been injected into BGP. So what I'm going to do is rerun my script again, my getter script. Okay, so Ansible playbook get.yaml. Do you notice anything wrong here? Here's a hint, it's related to what we had just configured. We see nothing here about a network statement. It's completely invisible to this RESTCON script. It's actually live on the box, but according to this output, it doesn't exist. But the problem is that it does exist. Watch this again. Let me add more to this configuration. I'll say router BGP 65001, and I'll say neighbor, all the 2s, and what I'm going to do is make this into a route reflector. Okay, again, let's check the configuration that's on the box. Okay, so we have a network being advertised into BGP, and we are now also a route reflector with the 2.2.2.2. That peer is now a route reflector client of ours. Again, let's rerun the script again. Clear U, arrow up.
And where is this configuration? We see no network statements and we see nothing about a root reflector, yet those configurations are definitely live on the box. Well, here is the problem, and something you really have to watch out for when you're using the CLI for this type of stuff, is that see the way I configured the network statement and the way I configured the root reflector client? I actually configured that via the legacy mode. This is the old way to do the configuration. And the actual Yang model is built off the new address family way. So when you're using this technique, you have to be very, very careful that you're checking everything is coming back right, and that you're not using some outdated legacy configuration. So let me make the amendments to the CLI and configure it via the address family, and things should iron itself out. Okay, so let's go in and amend this configuration on the CLI then. And we'll negate those old configs. So no neighbor root reflector client. And we'll also say no network, all the 23s. So show run section BGP. Okay, so let's configure this via the address family and see what happens then. So we'll say address family IPv4 unicast, and we'll add in the network statement 23s with the mask, and we'll also add in the neighbor for all the 2s and make it a root reflector client. Okay, so we've now configured it via the address family this time. So now if we do a show run section BGP, you can see that all this stuff is under the address family now. Let's run our getter script and see what happens now. Okay, so clear this, arrow up, run it again, and this looks a lot better. So straight away we can see we have the network and the mask, which is here. Our root reflector configuration is coming back. Now the neighbor is not actually up or activated, but that's immaterial for this demonstration. Key thing here to note is that if we're going to use this CLI method, which is really, really useful, always double check that the information is coming back as you expect, and also make sure you're using the latest version of the CLI. Don't be using legacy config. So this time we would copy all of this configuration and we'd paste this in, and this would be our YAML format with our root reflector client, and we'd also have a configuration for our network and our network mask. So definitely use this technique, involve the CLI within your automation. It's going to make your life a lot easier. But just really be aware and keep an eye out for these types of issues. Okie dokes, I hope this has been informative for you, and I'd like to thank you for viewing.